Good morning. Good morning. Today we are doing Geometry Lesson 8.1, the start of Unit 8, and this is an introduction to trigonometric functions. Now that's a big word to mouth, so you probably just want to use this part of it and call it trig functions. That's what most of us in the math biz do. All right, and so you're going to be able to recognize and calculate proportion ratios. Now, we've been doing proportion ratios with triangles. So we're going to be comparing angles to sides in triangles, and we're going to use the unknown corresponding angles, okay? And this video supports IXL Skill 4.1. Be sure to upload your notes to me by 11:59 p.m. Saturday, okay? All right, so what are trigonometric or trig ratios? A trig ratio is a ratio of the lengths of two sides of a right triangle. So we're looking at right triangles here. And the word is derived from an ancient Greek word, and it just means the measurement of triangles. And so here we got a fancy word now, but it was once a very basic word. The three basic ratios are called the sine, the cosine, and the tangent. And they're abbreviated as shown here, SIN or sin, cos, and tan. I'm just going to call them sine, cosine, and tangent, but in most cases I'm going to use the abbreviation when I write. All right, so these are the ratios. So we got a right triangle here, ABC. And the sine, the cosine, and the ratio of angle A, and so angle A, of course, is this angle right here. They're as follows. So what we're going to do is we're going to be looking at the sine of A, and the sine of A is, and this is all very kind of situational. Depends on which angle you're using, because you could actually do the sine of A or the sine of B, and you could do the cosine of A or the cosine of B, or the tangent of A or the tangent of B. But we're just going to find the ratio. Sine of A is the ratio of the side opposite of angle A. So we got to look over here to the opposite side, okay? And they show that a measurement as little a, and then over the hypotenuse, which is C. So that's why you have A over C. The cosine would be the side adjacent to angle A. So the side adjacent to angle A would be B over here, divided by the hypotenuse again, which is C, okay? And then the tangent of A is just the ratio formed by the side opposite of A, so that's little a, over the side adjacent to A, the little b, okay? So you have to just simply work this out, and I'm going to show you a convenient way to remember this. So if you want to say opposite and adjacent, so for sine, I abbreviate opposite over adjacent into this convenient anagram. So I got S-O, okay, and, this is opposite over hypotenuse, H. So S-O-H, that's the sine. And then the cosine, C, is adjacent over hypotenuse. And so we would take those three letters and we'd have C-O-H, okay? And then lastly we have tangent, and that's opposite over adjacent. And these ratios are the sides of the triangle that are relative to, in this case, angle A. And so this one, TOA, we show it like this. And so then we take this, to remember it, we remember this abbreviation, so, and this is A. Sorry, I didn't put the A in right. So this is A, C-A-H. So, ka, toa. So I remind people about the ratios using this simple, I'm trying to think of the word, it's not an anagram, but these letters representing these words. So it reminds me of a Japanese samurai, and I've heard this said before, so ka toa. So if you can remember that, then you'll know that the sign, the sign ratio is sine equals opposite over hypotenuse. Cosine is cosine equals adjacent over hypotenuse, and tangent is opposite over adjacent. You got those three, you can remember it. Okay? All right. Memorize that. It's important to memorize that. Okay? And then let's find the ratios now. This is our first example. I want you to compare the sine, cosine, and tangent for A in each triangle below. So I've got two triangles, a large triangle and a small triangle, and I've reproduced a table here, and I've done most of the work in advance for you. So the sine of A here for the large triangle is, let's see, opposite of the opposite over hypotenuse. So opposite is 8, and the hypotenuse is 17. Now what I'm going to do, and you'll notice I have wavy lines here, you're going to find with most of these trigonometric functions that your answer is going to be some decimal, and that's the case here. So if I take and clear this and I do 8 divided by 17, I get 0.4705 yada yada yada, and it goes on, and so we're just going to round that to approximately 0.4706. So I'm going to write that 0.4706. Okay, and then for the small triangle, it's going to be opposite. It's 4 over hypotenuse at 8.5. So 4 divided by 8.5 is going to be well, look at that. It's the same exact decimal for these two different ratios. So what is that telling you? So it's approximately 0.4706. So it shows you that because these two triangles are similar, their ratios between these two are going to be the same for the corresponding sides. So in this case, opposite over hypotenuse in the big one, its ratio is going to be the same as the opposite over hypotenuse of the little one. The signs are going to be the same. All right. Let's just look at the cosine. So that's going to be adjacent over hypotenuse for the large one. So adjacent is 15, hypotenuse is 17. So let's go ahead and take 15 divided by 17, and we get 0.8823, which rounds up 88235. So that rounds up to 0.8824. And so since these are similar, the small triangle's ratio for its cosine should also be the same. So 7.5 divided by 8.5, again, adjacent over hypotenuse, 7.5 over 8.5, the hypotenuse, is going to equal the exact same ratio in decimal form as with the large triangle. So I got 0.8824. Okay. All right. Last one. Tangent. Opposite over adjacent. So for the large triangle, opposite is 8. Adjacent is this side over here. It's 15. For the small triangle, it's 4 over 7.5 again. So let's take 8 divided by 15. And let's move it up a little more. 8 divided by 15. And we get 0.5333. So 0.5333. Double check it with the other ratio. 4 divided by 7.5. Enter. We get 5.33. 0.5. I'm sorry. Point. Yeah. Let's do that again. 0.5333. Okay. So, from this, you can see that similar triangles are going to have the same ratios when it comes to the sine or the cosine or the tangent of any given corresponding angle, in this case, angle A. All right, let's move on. And we're going to reproduce it here and here. And I actually have already, to be more specific, but you've got triangle RST. And in this case, we want to find the sine of S. That's this angle right here. So in this particular problem, down here, we want to find the sine of S. Let me highlight that a little bit. So we want this, sine of S. And so the length of the hypotenuse is, well, this is the hypotenuse, it's 13. And the length of the opposite side is got to be, what is it, 5? And the length of the adjacent side, I put it down as 12. Okay, and there it is. So let's go ahead and do opposite over hypotenuse. So opposite is going to be 5. So I'm just going to continue this here. I've got sine of S equals opposite over hypotenuse. So the opposite from S is 5, and hypotenuse is 13. So I'm going to go ahead and divide that. So let's clear this, and I'm going to do 5 divided by 13, and I get 0.3846. Okay. And then I'm going to go do the same thing with the cosine. And so the cosine is adjacent over hypotenuse. So here's S. Its adjacent side is 12. So it's 12 over the hypotenuse again is 13. So that's going to be 12 divided by 13. Okay, and that's 0.923. Okay, so this equals the sine of S. This equals the cosine of S. All right. And then tangent is going to be opposite. So the opposite is 12 over, I'm sorry, it's 5. Opposite is 5. And the adjacent is 12. So that's going to be 5 over 12. So 5 over 12 is 0.4166. So that's the tangent of S. Now, what are these? Actually, let's put the whole thing as the respective answers for each of these. What are these? these are ratios of sides of the triangle as they relate to a certain angle. In this case, the sine of s. We haven't gotten into how we're going to use these, but we're going to use these ultimately to figure out the lengths of sides that are missing. Okay? All right. So let's look at this last one. So in this case, the length of the hypotenuse in this case is, again, it's 13 this time. Well, it is the same. And the length of the opposite side is 5. And the length of the adjacent side is 12. But this time we're going to do the sine of r. So r is up here in this corner, right? So where's the opposite side? So find opposite of r, it's 12. Where's the hypotenuse? Well, it's still going to be 13. Notice the hypotenuse never changes. And so 12 divided by 13, well, we've got that answer up here, but it's for a different one. So let's just see if it's the same. Should be the same because it's the same ratio, 12 divided by 13. Let's find out. 12 divided by 13 is 0.923, which was what we had up here. So yes, it is. So that's the sine of r. But the interesting thing is that was the cosine of s. Okay? So you'll want to ponder why that might be. Obviously, the ratios are the same. But again, it's all situational. It's based upon what angle you're using to come up with these. Okay, so cosine of r. Cosine of r is going to be adjacent over hypotenuse. So here's r again. Its adjacent side is 5 over the hypotenuse. So 5 over the hypotenuse, which is 13. Well, isn't that the same as the sine of s? Yeah, ratios are the same. So this has to be 0.3846. But in this case, it's the cosine of r. Okay? So again, it all depends on where your angle, which angle you're using, and then you're looking at the opposite of that angle or the adjacent of that angle. And the hypotenuse, of course, is going to always be the same. So tangent, opposite over adjacent. So tangent of r, opposite is 12, adjacent is 5. Do I have anything like that up here? No, but I have 5 over 12 here. They're inverses. So the tangent of s and the tangent of r are inverses of each other because you flip the fraction. So what is 12 over 5? 12 divided by 5 is 2.4. And that's the tangent of r. Okay? So those are all of your respective answers for those. Understand that this is situational. So you're going to take this now and you're going to do, what did we say? It was IXL R.1. And so that's where we're going to start. And we will see you in a bit. Thank you very much. Bye-bye now.